Hi, this is 5.3a. Okay, we're going to look at limits again. The limit of 1 over x as x approaches infinity. Let's put a 1 into x. If we put a 1 in there, we get 1. If we put a 2 in there, we get 1/2. If we put a 10 in there, we get 1/10. And if we put 1,000 in there, we get 1/1000th. So we can see the number is getting smaller and smaller and smaller as we approach infinity. This becomes smaller and smaller, and it is approaching 0. Okay? Now let's go to the next one. The limit of 1 over x as x approaches 0 from the right. So we're coming from the right. So let's start with 1. If we put a 1 in there, we get 1. Now we're approaching 0, so let's try 1/2. 1/2 is 1 over 1/2, which equals 2. All right, let's try 1/10. 1 over 1/10 is 10. Okay, let's try 1/1000th. 1 over 1,000th, 1 over 1/1000th, okay, it's going to be 1,000. So we can say, as we approach 0 from the right, what's happening over here? 1, 2, 10, 1,000. It's getting larger and larger. And so we say this is going towards infinity. Okay? Now when we take the limit and it goes towards a number, we say this is converging. So I'm going to say this is convergent. Okay? And when we go towards any number and it's going towards infinity, we say this is diverging. And I'm going to say this is divergent. Okay? Now we're going to look at some definitions. Okay? All right. Okay, improper integrals. Improper integrals. Okay, so if we integrate from a to infinity of f of x dx, what that equals is the limit as b approaches infinity of the integral from a to b f of x dx. Okay, so we're going to utilize this. Here's an example. If we integrate from 1 to infinity 1 over x to the 1.1 dx, that equals integration from 1 to infinity of x to the negative 1.1 dx. And so since it is an improper integral in the sense that it's going to infinity, then what we're going to do is we're going to take the limit and we're going to change this. We're going to rewrite this as a limit as b approaches infinity from 1 to b of x to the negative 1.1 dx. Okay, so let's continue on this. We still need to write our limit sign as b approaches infinity, and then we're going to go ahead and integrate from 1 to b. All right, so we add 1 to our x, and we get x to the negative 0.1, and then we divide by that same value, negative 0.1. Okay, and now we're going to evaluate that. We'll put our b in there, and we get b to the negative 0.1 over negative 0.1 minus, now we're going to put our 1 in there, 1 to the negative 0.1 over negative 0.1. Okay, so let's keep going. Limit as b approaches infinity. Now what does this equal? Well, this happens to equal negative 10. 1 over negative 1 of 1/10 is going to be negative 10. Okay, and b it's just going to be 1 over b to the negative point. I'm not sorry, not negative, just 0.1. 1 over b to the 1. Okay, very good. All right. Now, this is a minus times a minus is a plus right here. This again is going to be 10. All right, and if we put a 1 in the negative 1.1, we're just going to get 1. Okay, so what are we basically taking the limit of? Let's rewrite this again. The limit as b approaches infinity of negative 10 over b to the 0.1 plus 10. All right, so here we have b approaching infinity. And remember, when this number gets larger, 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 this whole thing goes off to 0. So that goes to 0. The limit of b approaches infinity of this right here goes to 0. And the limit of any constant is just the constant. Okay? So this equals 10. So what we can say now is that this is converging. All right? And what we do say is we say, if we're looking at the integral and we're asked, is this convergent or divergent, because it is a number and not infinity that goes on forever, we say this is converging. So another way, we just write it's convergent. So we say the integral is convergent. Okay. Let's do another one. All right. So here's another one. We're going to integrate from 1 to infinity of 1 over x to the 0.9 dx. Okay, so let's go ahead and change that, integrating from 1 to infinity of x to the negative 0.9 dx. Okay, now because we're going to infinity, we have to change this to limit as b approaches infinity, and that's going to be the integral from 1 to b of x to the negative 0.9 dx. Okay, from now we can integrate, but we need to continue with that limit. So limit as b approaches infinity, and now we integrate. We're going to add 1 to negative 0.9, and that gives us 0.1 over 0.1. And we're going to go from b to 1. All right? So this equals the limit as b approaches infinity. We're going to put a b in the first one. This is b to 0.1 over 0.1 minus 1 to 0.1 over 0.1. Okay? Now what does this equal? The limit as b approaches infinity. This is just going to be this 0.1 down in the denominator becomes 10. B to the 0.1 minus 10. Okay, so now we can take the limit. If we go towards infinity and we put infinity in there, you can think of it that way, this number just keeps getting larger and larger and larger. So this goes to infinity. And this would just go to negative 10. But what is infinity minus 10? It's just infinity. Okay? And so, is this convergent or divergent? Correct, it's divergent. Okay, very good.